I'm Max Steele. You have seen me as such fine quality chemistry educational videos as Stupid and Chemistry, Not a Good Combination, and I Blew Up the Lab, Now What? Today we're going to do a model of equilibrium. And of course the idea behind equilibrium is you have the reaction that would go back and forth at some kind of a rate that it was consistent, it was constant. And we had talked about that in class. Okay, so for this particular lab, we're going to use a model to represent an equilibrium reaction. And what we're going to have two 25 milliliter graduated cylinders. We're going to have two of the large diameter straws. And we're going to have a small diameter straw. And we're going to have a little pipette or a dropper, depending what they like to call it. Now, I also happen to have a little container of water so that you guys can see what we're doing. Now, first thing, you're going to fill up one of the graduated cylinders up to 25 milliliters of water. Now, here, make sure, and I'm going to use my pipette, I'm making sure I'm using my pipette, that I can actually go and get this down to 25 milliliters, okay? Now make sure you don't have any air bubbles in here, okay? Tap it a little bit and whatnot. You're gonna use regular tap water for this. Make sure the other cylinder is empty, okay? And we're modeling an equilibrium, so the idea is that one side of the reaction has got everything. It is all of the initial concentration, and the other side of the equilibrium reaction has zero concentration. So this is what we have. Now, what we're going to do, you're going to need one person per straw. I am not joking about this. That would be important. And you're going to take the large diameter straw. We're going to work with that first. So we're going to put one down here and one over here. Now, the idea is that we are going to switch the straws back and forth filled with water. Now, obviously, we have no water in this cylinder. We have all 25 milliliters of water. So I'm going to take this one out, and we're going to say that it's being transferred over to here, and that's it. I'm going to wet my finger a little bit because the idea behind wetting the finger is that you would get a seal here. And what I found working with this, you have to get that seal, and it's very important. You have to wet your finger every single time you do this. So the two people who are going to be doing the transfers, they're going to need to wet their finger. It's just plain water, no big deal, no risks. All right, and what's going to happen, the reason why you're doing that is you are forming a wet seal around this. And then here's what you're going to do. You're going to lift it up like this. Take it over to the other cylinder and let go. And you notice, oh, look, there's some water in here. So you're going to have to go and take the measurement reading of that. How many milliliters of water you got? Put that there. And you're also going to take your volume reading of your water over here. So what are we doing? We're starting to model an equilibrium reaction. We've got it going. So we have got some product being made. Here's our reactants, okay? Now you notice that we have our straws are now back in there. And remember, it's going to take one person per straw to do this. So again, you're going to wet your finger, okay? Now I'm doing this two-handed, but the idea is you're going to switch like that. Guess what? I'm a boss because I just did it. One-handed each way. Yes. I tried doing that earlier and I failed. It worked. It worked out. So we do the same thing here, and you notice, okay, there's a different increase in the levels here. So this has got some more. This has got a little bit less. And then again, you'll wet your fingers, and then you get to do it. Oh, and you noticed why you have one person per straw, because you noticed I just spilled. Not a big deal, it's water. Okay, I haven't known anybody who was allergic to water, but I wanted to show you this particular lab. Now, this is going to be one trial run that we're going to do this. We're going to do a second one where we're going to fill it up to 25 milliliters. I think I've lost a few milliliters here, which doesn't surprise me. So I'm going to go ahead and I'm going to take it from the pipette to here. Now remember, this is a model of an equilibrium reaction. Okay, there we go. So this is what we have, except this time, according to the directions, I think we're going to have one of these straws here and the other straw in here, but we'll have to consult the instructions, shall we? Now we have a smaller diameter straw. Here we have the regular straw that we used in our last experiment here. So what do? You're going to wet your fingers. Again, you need a person per straw, and you're going to switcheroo like this. Okay, and if you notice this one, I lost some water on the way through. I can't help that. I'm just a one-man production crew here. But I'm going to take this straw out so you know. And I'm going to wet my finger, and then you'll notice I'm going to take this straw, I'm going to lift it up now. You know that there's a water level here, so try to not get any drops out, and we can do that. So you notice certainly the rate that it's going down, it's decreasing. So anyways, now you have an idea about what to do specifically in this lab, and you're going to be recording your volumes and the number of trials that you go through. There's probably going to be a point where you're not going to be able to transfer any more water, either on one side or the other. There is a maximum number. I don't know the number off the top of my head. I'd have to look up my lab. But that's basically how you do this for the equilibrium lab. It looks simple. It's not. But anyways, that's it for the equilibrium lab. And, well, have fun doing it. Take care now.